So, we're kicking it off this morning. Very glad to be here. I know there's still a lot of people coming in. Let me just get a show of hands. How many of you have heard of Hashgraph? Wow, most of you. Okay, great. I'm very glad to hear that. Let's get this started. Presentation. There we go. So what is Hashgraph? Hashgraph is, first and foremost, not blockchain. Hashgraph is an alternative to blockchain. Blockchain is a term that describes a data structure and a consensus algorithm. Hashgraph is similar in that regard. Lehman Baird, PhD from Carnegie Mellon, my business partner, the inventor of Hashgraph, back in 2012 decided that he wanted to sort of tackle this problem of distributed consensus at scale. He had a vision for how he thought the internet should work, how people should be able to play together and work together and exchange goods and services together without the need for a trusted central party with whom you have to trust your identity and data. And he went to work, and it took 3 years before he had a breakthrough in 2015. Today, we call that breakthrough the Hashgraph. So the Hashgraph, in short, has fantastic properties as it relates to blockchain. It is secure. It achieves the very best level of security that one can achieve in the field of distributed consensus, something called asynchronous Byzantine fault tolerance, which I'll touch on. It's fair. It's fair in some fundamental ways that no one else in the market achieves. Basically, it's not possible for a single party to prevent a transaction from flowing into the network, nor can a single party unduly influence the order of transactions that the community ultimately agrees on. So what does all that really mean practically? What it means is that for the first time, it's possible to build a whole set of distributed applications that previously would have been insecure. For example, distributed auctions. Who pushes the button first in an auction makes all the difference in the world. Or a distributed stock market, the matching platform, having bids and asks flowing into the network. You don't want one party to be able to prevent a bid from flowing in or influence the order of the bids for the market as a whole. That wouldn't be a fair market. Or games. When we have a multiplayer game and two people reach over to pick up the pot of gold, which one actually pushed the button first is important. And this fairness property makes it possible to build those types of applications for the first time in a fundamentally fair way. And then finally, it's fast. And it's really fast. And I'll be giving you some details on that shortly. So we started Swirls in 2015. And we first went after the enterprise market, and we got enterprise customers. And that was by design because of our plans for a future public platform. And you'll understand why here as we go through this. But last year, we got to the point where we had enough market validation that we could begin to think about building a public platform. And we spun out a new organization in the fall. And that we introduced in New York City on March 13th of this year, just about 6 weeks ago, Hedera Hashgraph. Hedera is a new company that's a peer of Swirls that's chartered with taking to market the first public platform built on the Hashgraph consensus algorithm. So when considering what problems that needed to be addressed that prevent mainstream adoption of public networks today, we came up with 4 categories. We took a step back and said, why is it that after years of availability in the market, there's still no enterprise-grade applications running on any of the public platforms today? And we identified these 4 categories of problems that needed to be addressed. First, you just can't do much with 5 transactions per second, right? And everyone knows it, and everyone's trying to solve this problem. And there are a lot of proposed approaches for solving the problem. But what we need minimally is hundreds of thousands of transactions per second within a single shard, within a single subnetwork. And then maybe at scale, millions or more in a fully sharded solution. And we need the community to be able to come to agreement on the order of those transactions in seconds, not an hour or longer. That makes a huge difference in what is practically possible with respect to the technology. Also, if it's the case that we're going to be transferring value, trillions of dollars of value across these public platforms, then we know that they're going to be attacked, and we have to prepare for that. And what that means is that you have to start at the very bottom of the stack. You have to build the very best security into the stack that you can at the algorithm level. In other words, you have to start with solid math first and build that into the platform itself. If you can solve the technology problems and you can solve, performance and security, then there's this issue of stability. Now, the open source nature of our industry has been fantastic for innovation and driving the market forward in some very fundamental and exceptionally fast ways. But there is a flip side to this, and that is that if I'm a business manager and I'm considering spending $2 million to build an enterprise application on a platform that I know is very likely to split, to fork into a competing platform and associated cryptocurrency in the near future, well, that causes me pause. That represents risk. And somehow we have to get over that to get to mainstream adoption. We need to maintain both open innovation with transparency, not a black box, but at the same time we need stability in some ways that we don't have today. So that's a problem that has to be addressed. And then finally, governance. If we can solve all of those problems, then what is the appropriate governance model that will cause mainstream markets to adopt, that will cause mainstream markets to trust the platform and the organization behind it? Hedera has answers for all these. Hedera has, using the Hashgraph algorithm, has performance that is measured in the hundreds of thousands of transactions per second. I will give you specifics here momentarily. And it does achieve seconds of consensus latency. And what I mean by that is within seconds, the community comes to agreement on the order of transactions, and it's not probabilistic. It's with 100% certainty that the order will never change again in the future, and it comes with the math proof that you can take to a court of law. Like I've already mentioned, Hashgraph as an algorithm achieves the best that one can achieve in terms of security at the algorithm level. Asynchronous BFT, well, what does that mean? It means that there are categories of attacks that simply are not possible to levy in a practical way against an asynchronous BFT algorithm that you can use against everything else. Anything that's less than asynchronous BFT has to deal with some types of distributed denial of service attacks that can potentially cripple a system. And it's a big deal if you're trying to build a platform that will always work. If it's responsible for transferring trillions of dollars of value, you want to know that you've got the best security that you can achieve, theoretically and practically. Hashgraph achieves that. So what about stability? Hashgraph has a couple of mechanisms that other platforms in the market today don't. One, there are technical controls in place that make it possible for us to prevent confusion in the event there was a fork in the platform. But secondly, Hashgraph as a technology is patented. And we always are asked, why? Why did you do this? Why don't you open source the technology? Well, the answer is we're going to use it as a governance tool in a very fundamental way. So let me start by saying there's no license required to use this platform. It's just like Ethereum or any of the other public platforms. If you want to build product on top of this, You can do so. You simply make API calls, and assuming you have tokens from the platform, the cryptocurrency associated with the platform, you make micropayments at the same time. For each API call, you make a micropayment for the use of that API. There's no license required. The code you develop is your code. So it can be open source, it could be proprietary, it can be anything in between. In fact, we won't even know what products you are building on top of our platform unless you decide to tell us. So no license is required to use the platform. Secondly, with version 1 of this, we're going to release the source code. So there will be full transparency in exactly what is being built. Everyone on the planet will be able to download the source code. They'll be able to read every line, every single line of the code base will be released. You'll be able to compile it and compare it to the binaries that you can download and run on your own home computer as a node in the network, supporting the network in total. So there's transparency in the code base. However, we're using the patents in a novel way, and that is with the patents insofar as we are able to enforce, we are making a promise to the market that this platform will never fork. There will be a single platform and a single cryptocurrency forever with Hashgraph, with Hedera Hashgraph. Now, I do clearly understand that there are developers in the market that simply will not like this. And their objections are sometimes legitimate, right? So if a developer wants to build a product on a platform and they, at some point in the future, don't like the product roadmap of that platform, sometimes they want the ability to fork that platform, change it, and go to market and compete with the same platform and their own product roadmap, both for the platform and for the applications being built on top. And you know, that's legitimate and that's okay. But I think that this introduces an option to the developer community that didn't previously exist, and we believe very strongly that there is a market of developers that care about stability. And they're not going to be the ones that are building a competing platform. And they're looking for a platform that provides this type of stability that we, for the first time, are providing. And for those that don't want to use it, there are dozens of other platforms out there that they can use. So if you can solve those problems, if you can solve the performance problem, the security problems, if you can provide stability, then the question is, what's the right form of governance? To answer that question, I started by reading a book. There's a gentleman by the name of Dee Hawk who is the founder of the Visa network back in the 1960s. And Dee outlines the process that he went through when designing the governance model for the Visa network. And he had to grapple with all the same problems that we have. We need representation from around the planet, from all major markets and all constituencies. And we want to ensure that no single organization has more or less control than any other organization within the Governance Council. We wanted to build a council that represents the most decentralized governance council of any of the public platforms in the market. So we applied the same design principles that Dee Hawk outlined in his book. And what that looks like for us is a global council of 39 members. These members represent the very largest organizations on the planet. Each member individually has tens of billions of dollars of market cap, and they have the very best and most trusted brands in the market. And they're not a bunch of banks. They're a few banks. We want to cover 18 sectors of the industry in every major market around the globe. So there are a few banks, there are tech giants, there are telcos, there's transportation, there's insurance, there is there are global law firms and global consultancies, and on and on and on. And they're not all in the US. We currently have representation from Australia, from Asia, from Europe, from the United States. We're preparing to pick up, well, we've already picked up India. We're preparing to pick up the Middle East and South America. And we still need representation from Africa. We have more than half of the 39 already committed. And we anticipate that we'll have the remainder of the 39 by the end of summer. And we will begin making announcements about who these members are in the coming months. Also, it's important to know that Swirls, the parent organization, is just one of the 39. It has no more or less control than the 39. And these 39 aren't members forever. They're term limited. So it's possible for them to spend up to a total of 6 years in the council, 2 3-year terms within the council. So they know and understand that the decisions that they're making, they ultimately have to live with for the platform on this global basis. They are stewards of the organization, and that's how the governance model has been designed, for them to realize that. Additionally, they're not doing this for the money, right? No single organization here, the revenue that they potentially would receive from running nodes in this organization is so tiny compared to what their market cap is. That's not why they're doing it. They're in this because they see an opportunity to help be stewards of the next generation of the internet. And that's how they view it. So what does this platform look like? Well, here it is. We have the internet, and then we have the Hashgraph consensus platform that we've been developing now for years and first used with enterprise customers. We're adding 3 services on top. First, cryptocurrency with native support for micropayments, meaning that there is no layer 2. There is no Lightning Network. There are no side chains. It's all on graph. Direct support for micropayments using the native cryptocurrency. Distributed file storage. So this is Byzantine, and what that means is that when you store files in this platform, you get a proof that they've been stored from the community, but almost more importantly, if you delete a file, you get proof that it's been deleted by the community, which is really important when we begin to think about privacy concerns and issues raised from legislation like GDPR, for example. And then finally, smart contracts. We've taken the Ethereum virtual machine and we put it directly on top of the platform. We have backward compatibility for Solidity smart contracts. So where are we in this process? We'll be feature complete this month, the middle of May. And we have dozens of partners that are lined up now to begin development on this platform. The APIs are now locked down. The public APIs are locked down, and they will begin development later this month in May. What about the coin? So the coin is actually required for the security of the network. And this is a proof-of-stake system. So let me explain what this looks like and how we bootstrap this proof-of-stake system. The math works out such that as long as not more than 1/3 of the coins are held by a bad actor, then the network is fundamentally secure against certain types of attacks, Sybil attacks specifically. So to start, Hedera as an organization will hold 2/3 of the coins in treasury. What that means is that the 39 members that I described will each vote the weight of their pro rata portion of those coins, each voting 1/39 of the weight of the coins. So the 39 will control initially 2/3 of the weight of the coins. What that means is we can float up to 1/3 of the currency into the market. And it doesn't matter if a bad actor collects all of the coins in the market. They can't prevent the network from coming to consensus. At such time when the value of the token is sufficiently high and broadly distributed enough, the council will elect to begin to sell down treasury. And so when that point comes, the Hedera treasury of tokens will be sold down into the market. The cash, the fiat, will flow into treasury, and it will sit there. There will end up potentially being billions of dollars of cash in treasury, and that will be used as a governance tool as well. The 39 can't touch it. They can't dividend out the cash. No one's going to take that fiat. It's going to sit there. And Hedera, as an organization, will represent a natural buyer of the tokens in the market when market conditions dictate, which provides us a tool that others don't have in the market. So what about performance? Visa has on average 2,000 transactions per second. And the terms of service require that when you use your credit card, you need to get the answer back, can I use that card, within 7 seconds. It's a little bit hard to see. There should be a 7.0. 7 seconds is the terms of service. With Hashgraph, in 8 regions, we demonstrated 2,000 transactions per second with a 2.9 second consensus latency, meaning that the community comes to 100% certainty on the order of transactions in less than 3 seconds. But then we upped the number of transactions per second, and we went to 50,000 transactions per second. In 8 regions around the world, we were able to do that in 2.9 seconds of consensus latency. We decided to push it further, and so we went to 100,000 transactions per second. In 8 regions on a global network, the consensus latency only went from 2.9 to 3.4 seconds of consensus latency. When we went to a single continent, North America, and we performed these same tests across North America, we were able to achieve 250,000 transactions per second with a 3-second consensus latency. So the algorithm itself is no longer the bottleneck. It turns out the bottleneck showed up in a different place. It's in the signature verifications. So if Alice wants to pay Bob a coin, she creates a transaction, she digitally signs that transaction, and then she sends it to the network. Well, if you're trying to verify 250,000 digital signatures per second, that's pretty hard. So we worked with one of the 2 global GPU manufacturers to create a library. They actually wrote a library on our behalf that does signature verification in parallel on GPU. And the question is, could we achieve hundreds of thousands of signature verifications per second? And the answer is yes. We're able to achieve 1 million signature verifications per second. The final piece is in updating the account balances, and that's it. And our initial experiments indicate that that required level of CPU and storage access is not going to be a bottleneck. We expect to be able to do hundreds of thousands of transactions per second. So we've addressed the technology problems, the security problems, stability in a fundamentally new way, and governance. We have the most decentralized governance model of any public platform in the market. At scale, this will be a sharded solution. It's not a permissioned network. There will be hundreds of thousands of nodes representing full decentralization and distributed computation and consensus on a global scale. So where are we in this? We have customers. We have partners. These logos represent many of them. The credit union industry was our first enterprise customer for Swirls. They announced this morning with the press release that they'll be using Hedera for cross-border payments. Machine Zone is a partner. Gabe Layden is here. We'll be speaking this afternoon. VMS Software, one of the most stable versions of Unix for enterprise mission-critical applications. They've built this into their operating system. ArtBit, Matt Sorum from Guns N' Roses, announced a decentralized marketplace for artists to sell their products. They'll be using Hedera. Extreme Push for ad tech, Intiva Health for healthcare, and credentialing of medical professionals. So Hashgraph is now here. In terms of timelines, as I've already mentioned, people will begin development on this public platform in May. We expect to harden the platform through and into the fall, gradually opening up to more and more beta customers with the goal of being version 1.0 or generally available by the end of the year. That's it. Thank you for your attention. I appreciate being here.